Yesterday, a series of 3 magnitude 5 and 6 range earthquakes struck the Shimane Prefecture of Japan, causing minor damage and even some scattered instances of liquefaction damage. For reference, liquefaction damage typically looks like these images, although in yesterday's instance, it seemed to be confined to road and ground cracks due to minor subsidence. The largest of these earthquakes was somewhere between a magnitude 5.7 and a 6.4 depending on what source is citing its magnitude, but regardless caused ground shaking that was felt up to 400 kilometers from its epicenter. Even one of my patrons living in Osaka felt the largest of these events, experiencing MMI3 intensity shaking across the quake's 11-second duration. As for the strongest ground motion an individual spot experienced, that was equivalent to an MMI6 shown in this simulation. With this established, you might be wondering why I am talking about a sizable but ultimately fairly harmless earthquake sequence, because typically my earthquake discussion videos are reserved for more damaging seismic events. The answer boils down to 2 scientifically interesting concepts being well portrayed by this January 6, 2026 earthquake sequence. The first aspect of note is that the earthquakes and aftershocks which struck occurred on 2 strike-slip fault lines that were almost perfectly 60 degrees apart from one another. This pair thus represents a textbook example of what is referred to as a conjugate fault, which form under the same stress conditions and ideally if involving strike-slip faults are exactly 60 degrees apart. The same reasoning is why smaller fractures with the same angles also tend to be fairly common in various rock units, such as this photo taken in Bar Harbor, Maine. Second is where the earthquakes occurred. If we were to plot every single magnitude 5 or larger earthquake that has struck Japan and was recorded by modern equipment, we get a nice even distribution once you get away from the plate boundaries until we get to the segment around Shikoku Island and to its north. Here, the greatest density of such magnitude earthquakes occurs along a broad lineament of sorts which runs through both Totori and Shimane. While this is known as a string concentration zone, it is best to instead think of this area as a zone where larger magnitude earthquakes are more likely to occur than the regional vicinity, as faults here can best accommodate building regional strain. This is why 3 magnitude 6 and 2 magnitude 7 range earthquakes have struck here within the aforementioned zone in the last century, which can also be referred to as the Sin and Shear zone. As you can see in this chart, the shear zone originated due to a local variation in the rate of motion and direction of the overall Amur tectonic plate. This caused strain to build up until a portion of it was released via a series of earthquakes yesterday morning. The largest earthquake struck at 10:18 a.m. local time, which was followed by a magnitude 4.7 to 5.1 earthquake at 10:28 a.m., and then at 10:37 a.m. a magnitude 5.0 to 5.4 quake struck. The latter 2 events were by definition aftershocks, with the 10:37 event likely passing the general average largest aftershock threshold for a standard earthquake sequence. Dozens of additional smaller magnitude aftershocks have already struck, occurring on the 2 trends of conjugate faults. All of these events occurred at approximately 10 kilometers or 6.21 miles depth or less, indicating what are most likely to be a series of buried fault lines. The rate of aftershocks is most likely to continue declining as time since the largest quake in the sequence increases, with the chance of another magnitude 6 or larger quake in the vicinity being quite unlikely. And since I know someone will ask this, these seismic events were completely unrelated to the earthquake storm which occurred in 2025 beneath southwest Honshu. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube for supporting my work.